Greetings, everybody. Let's talk a little bit about maybe computing a specific problem involving arc length. And so we're given a curve that says of the form r of t is going to be t squared plus 1 and 4t cubed plus 3. So we want to find the arc length of this curve with t going from -1 up to 0. So one thing that we need to remember is that our arc length form, our ds, is really going to be equal to the square root of dx squared plus dy squared. Now dx is just our regular differential, dy is our regular differential. So if we plug in dx is equal to dx dt times dt, then we get an expression of the form the square root of dx dt squared plus dy dt squared and dt. Well, if x is t squared plus 1, then dx is going to be 2t. If y is 4t cubed plus 3, then dy dt is going to be 12t squared. If we plug those in for dx dt and dy dt, then we get an expression like this. So we have 4t squared plus 144 t to the fourth underneath the square root. Now we can factor out a 4t squared from that. So if we factor out a 4t squared, that's going to give us with a 2 times the absolute value of t times the square root of 1 plus 36t squared dt. Okay. Well, knowing that t is going to be between -1 and 0, if we take the absolute value of it, that's going to be equal to negative t. And so our ds kind of has the final simplified form of negative 2t times the square root of 1 plus 36t squared dt. Well, if we plug this into our arc length integral, then we got s is equal to the integral over our curve gamma of ds. Well, that's just going to be the integral from -1 up to 0 for our range of t. And then our ds, which was our negative 2t squared of 1 plus 36t squared, we then do a u substitution with u equal to 1 plus 36t squared. Du becomes 72t dt. If we plug that in, we get an integral from negative 270 seconds with the times the integral from 37 up to 1 of the square root of u du. Well, if we switch the order of integration so that it introduces a negative, that kills off the negative here, and so we have, simplifying that fraction, 1 over 36 times the integral from 1 up to 37 of the square root of u du. Well, just the power rule on that one is going to give us this expression. And so plugging in our limits from 1 up to 37, we get a final answer of 1 over 54 times 37 to the 3 halves minus 1, which, if we just kind of plug that into the calculator, that's going to give us a numerical answer of about 1.1493. So I hope this has kind of been easy to follow, at least for that one, and I'll see you again in the next homework problem.